Good morning, all of you. Welcome to Standard 10th. Children, today I'm here with your chemistry lessons. Children, as you all know, chemistry is a part of science. You all have got to know about the bifurcation of science in 9th standard only. Chemistry contains all the chemical reactions and the chemical processes going on around you. In science, there are three parts: physics, chemistry and biology. The picture being displayed on the screen is of your NCERT textbook for standard 10th. The contents of the textbook are the 16 chapters. These 16 chapters have physics as well as chemistry as well as biology. The first 5 chapters out of these 16 chapters are of chemistry, namely chemical reactions and equations, acids, bases and salts, metals and non-metals, carbon and its compounds, periodic classification of elements. Children, in this academic year 2020-21, we have to cover these 5 chapters in chemistry. Children, I'm starting with the first chapter of your chemistry textbook, that is chemical reactions and equation. You all have learned about the physical and the chemical changes in class 9th. In class 9th, you all got to know that a change is called a chemical change when a new substance with a new property is formed during the change. Now, chemical reactions are any chemical change written in words. For example, if we consider the burning of a magnesium ribbon in air, when it is written as it is displayed on the screen that when magnesium ribbon is burnt in air, it burns with a dazzling white flame, producing magnesium oxide, as a new substance, that is magnesium oxide, is formed during the chemical change, so it is termed as a chemical change. Similarly, when a zinc granule is added to dilute sulfuric acid, hydrogen gas is released. As hydrogen gas is released during this change, so it is also termed as chemical change. Another example of a chemical change is when lead nitrate solution is added to potassium iodide. A yellow colored precipitate is formed. As a yellow precipitate formed is a new substance, so this change is also termed as a chemical change. Now children, generally when a chemical change takes place, or you can say when a chemical reaction takes place, then many things can be observed. Like in the first example of a chemical reaction, you all see that when a magnesium ribbon is burned, a gas is released. Generally, when a chemical reaction takes place, many things can happen, like the release of a gas, formation of a precipitate, change in color, or evolution of, or you can say the absorption of heat. Any of the things when taking place, they are called the characteristics of chemical reactions. That means when a chemical reaction takes place, any of these can take place. Children, now I'm showing you a video in which the burning of magnesium ribbon is being demonstrated.
Burning of magnesium ribbon is a chemical change. Take a piece of magnesium ribbon. Hold one end of it with a pair of tongs and heat the other end over the Bunsen burner or spirit lamp as shown here. It starts burning with a dazzling light and produces dense white fumes. The white fumes on cooling form a white powder called magnesium oxide. Magnesium oxide is a new substance and its properties are different from magnesium. Can we obtain magnesium from magnesium oxide by any physical method? Certainly not. Therefore, it is a permanent and irreversible change. Hence, it is a chemical change.
Now children, in the above video, you all have seen that when a magnesium ribbon is burnt in air, then a gas is released. At the same time, a white colored powder called magnesium oxide is formed. So, as the reaction is accompanied by the release of a gas and production of a new substance, so such a change is termed as a chemical change, and this, when written in the form of words as it is being displayed on the screen, is known as a chemical reaction. The other example of the chemical reaction that I have given you was when a zinc granule is added to dilute sulfuric acid, hydrogen gas is released. Now, you will see a demonstration of the above chemical reaction.
Procedure. Place a few pieces of granulated zinc in the flask. Pour about 20 ml of dilute sulfuric acid into the flask and fit the apparatus as shown in the figure. Take a conical flask with a suitable rubber stopper carrying a jet tube. Have a feel of the flask containing zinc pieces and dilute sulfuric acid. It appears warm. Perform the following test on the hydrogen gas produced in the flask. Test, experiment, observation, inference. Nature. Bring a moist blue litmus paper near the upper end of the jet tube. No change in color of litmus. Hydrogen gas is not acidic. Bring a moist red litmus paper near the upper end of the jet tube. No change in color of litmus. Hydrogen gas is not basic. Color. Observe the color of the evolved hydrogen gas. No color. Hydrogen is a colorless gas. Odor. Smell the hydrogen gas coming out of the jet tube. No odor. Hydrogen is an odorless gas. Combustion. Bring a burning candle near the open end, upper end of the jet tube. Hydrogen burns with a blue flame and popping sound. Hydrogen is a combustible gas. To confirm the presence of zinc ions in the solution at the end of the experiment, take about 2 ml of solution from the flask in a test tube. Add drop-wise sodium hydroxide solution. White precipitate once formed gets redissolved when excess of NaOH is added. The solution in the flask contains Zn2 plus ions. Observations. Thus we find that when zinc reacts with dilute sulfuric acid, two new products, zinc sulfate and hydrogen, are produced. The properties of the new products are entirely different than those of the reactants. When zinc interacts with dilute sulfuric acid, some heat is evolved. Result: the interaction between zinc and dilute sulfuric acid is a chemical change. Precautions: sulfuric acid must be handled with care. The test tube for the combustibility of hydrogen should only be shown to the students by the teacher. This test must be performed with utmost care.
Now children, in the above video, you all got to know that when zinc granule is added to dilute sulfuric acid, it results in the formation of zinc sulfate and hydrogen gas. You all also got to know about the properties of hydrogen gas. Hydrogen gas is neither acidic nor it is basic. Hydrogen gas is colorless and odorless, and it catches fire and burns with a blue flame and produce a popping sound when it burns. So hydrogen gas burns with a pop sound. Now the third example of the chemical reaction that we have taken is when lead nitrate solution is added to potassium iodide solution. Then a yellow colored precipitate is formed. Now with the help of this demonstration, you all will learn about the formation of precipitate, that is one of the important chemical characteristic of a chemical reaction. Here in this reaction, a yellow colored precipitate will be formed. So you all can now see the demonstration. Children, the reaction is a formation of precipitate.
Hello scientific people, how are you today? So today we are going to,
Children, it is taking time. Till then, you all should know that this formation of precipitate is also one of the very important characteristic of chemical reaction. And the other characteristics of chemical reactions are the evolution of any gas, as it happened in case of reaction between zinc granule and dilute sulfuric acid. Similarly, reaction of magnesium with air, that is oxygen. Now children, I think we should proceed further. Now, the next important thing is the chemical equation. A chemical equation is a chemical reaction when written in the form of when written using the symbols for elements and formulae for compound. In 9th standard, you all have learned about the symbols of different elements. Elements like your hydrogen, helium, lithium, sodium, potassium, rubidium, francesium, all these are elements. When any element, instead of writing the name of the element, we are writing the symbol for the element. And for the compound, like for water, we are not writing water, we are writing H2O, that is the chemical formula for water. Now when chemical reaction in the form of symbols of elements and formulae of compound, then such a chemical reaction is called a chemical equation. See children, here we have arrow. Now when magnesium reacts with oxygen. Oxygen present in the atmosphere. It results in the formation of magnesium oxide. This is that same chemical reaction that you have learned in this slide. This is magnesium ribbon burns in air, produces magnesium oxide. This was the chemical reaction, and now we are writing that same chemical reaction in the form of chemical equation, in which magnesium reacts with oxygen. This magnesium reacts with oxygen and result in the formation of magnesium oxide. This is a chemical equation. Similarly, the second chemical reaction that you all have learned was when a zinc granule is added to dilute sulfuric acid. When zinc granule is added to dilute sulfuric acid, it results in the formation of zinc sulfate and hydrogen gas. As hydrogen is a gas, we can make an arrow upwards. Here also an arrow is there. Now see, whenever we are writing a chemical equation, the substances which are present on the left hand side of this arrow, they are called the reactants, and those which are present on the right hand side, they are called the products. Now in this reaction, what is happening? Zinc reacts with dilute sulfuric acid and results in the formation of zinc sulfate and hydrogen gas. Here for zinc we have written the symbol Zn. For sulfuric acid we have written the formula. Zinc is an element, we are writing a symbol. Sulfuric acid is a compound, we are writing the formula, that is H2SO4. When the two react together, they result in the formation of products, and the products that are formed here are ZnSO4, that is zinc sulfate, and H2 gas, that is hydrogen gas. Now, the third example that we have taken for the chemical reaction was when lead nitrate solution is added to potassium iodide, a yellow PPT is formed. Children, the same chemical reaction I have written in the form of a chemical equation. In chemical equation, you all can see lead nitrate is a reactant written on the left hand side of this arrow. Potassium iodide, again the reactant written on the left hand side of the arrow. The two are the reactants. They two react together. This plus symbolizes the reaction. Now, when the two react together, they result in the formation of the products potassium nitrate and lead iodide. Here, a yellow PPT is formed. So, this is also an example of the chemical equation. You all must now be knowing about the chemical equations.